வாங்க ஒரு சிம்பிளான விஷயத்தை பார்க்கலாம்.
Welcome to today's explainer. So what does a data scientist actually do? We're going to completely demystify this role today. No jargon, just getting straight to the point of how raw data and math come together to solve literally massive real-world business problems. Think about it. Companies are churning out terabytes of information every single day. The ability to pull actual, actionable insights out of that mess, that's what separates the industry leaders from the rest of the pack. So let's strip away the confusion and see exactly how these pros turn total data chaos into strategic gold. Let's just bust a massive stereotype right out of the gate, okay? When you hear data scientist, you probably picture, a solitary genius sitting in some dark basement room, just furiously typing away at glowing green code like in the Matrix, completely disconnected from the actual business. Yeah, total myth. The reality is actually highly collaborative and way more interesting. A data scientist is basically a digital detective. Their whole job relies on this hybrid of deep domain expertise and rigorous scientific methods. They're investigators, looking for statistical clues hidden in the numbers, but they're always doing it with a really sharp understanding of the broader business context.
Here's our roadmap for today. First, we'll look at the digital detective workflow. Then, we'll walk through the 4 core phases: collect and explore, analyze with math models, visualize to find patterns, and finally, solving real-world problems.
Section 1. The Digital Detective. Uncovering the Workflow. Okay, let's dive into this. Because it really all boils down to these 4 interconnected steps. This is the exact, repeatable daily workflow. Collect, explore, analyze, and visualize. This flow right here, this is the secret to taking raw data from just an unorganized mess to a polished product that drives major executive decisions. To really wrap our heads around this, let's anchor it in a real-world scenario. Imagine a massive global retail chain trying to, say, optimize its supply chain and predict consumer demand. Every single project designed to tackle a problem of that scale moves systematically through these exact 4 stages.
Which brings us to Section 2, Collect and Explore, Gathering the Clues.
So the very first step when stepping out into the field to apply these scientific methods is collection. Before you can predict anything or solve complex puzzles, you need your raw materials, right? Data scientists use specialized tools to pull data from all sorts of pipelines. I love this quote because it hits the nail on the head. Think of it like baking a cake. You have to go to the store and collect your flour, sugar, and eggs first. In the context of our retail chain, going to the store literally means querying massive SQL databases for historical sales, pinging real-time APIs for current weather patterns that might change how people shop, and scraping web traffic logs from their e-commerce site. But wait, jargon alert. Once you have millions of rows of data, you can't just blindly feed it into an algorithm. You have to do what's called exploratory data analysis, or EDA. Don't let the fancy name fool you. Exploring just means inspecting your ingredients to make sure they're fresh before you start cooking. You're stress testing the information to see if it actually makes sense. You're checking for missing entries or identifying crazy statistical outliers that could completely throw off your analysis. Going back to baking, you wouldn't put a rotten egg in your cake, right? Well, a data scientist absolutely won't let corrupted transaction logs or broken API feeds taint their predictive models.
Moving on to Section 3, Analyze with math models, cooking the data. Now that we've got clean, beautifully structured data ready to go, we start actually cooking. We move to analysis using mathematical and statistical models. Time for another jargon alert. What is a model? Simply put, it's just a specific set of math rules or a formula. Honestly, it's exactly like finding the average of your test scores back in school, just scaled up. Now we are moving past basic math here. A data scientist might use a linear regression model to forecast future sales, or deploy a clustering algorithm like K-means to group customers based on complex behaviors. This is where the heavy lifting happens.
And to be clear, they are definitely not doing this by hand. During this phase, data scientists are relying on incredibly powerful computer tools. They apply these complex math rules to terabytes of data all at once. Because look, raw numbers sitting on a cloud server can't tell a story by themselves, and the human brain is literally incapable of processing correlations at that massive scale. By feeding all those numbers through sophisticated machine learning tools running at blinding compute speed, data scientists literally force the raw data to reveal hidden correlations and secrets that would otherwise be completely invisible to us.
Section 4, Visualize to find patterns, showing the masterpiece. Now, what's really interesting about this next part is
once the models finish running, technically you have your statistical answer.
But imagine taking this dense, confusing spreadsheet packed with tens of thousands of raw values, normalized scores, random transaction IDs, and just dropping it right onto your boss's desk. Yeah, no way, they'd be totally lost. Executives just do not have the time to decipher raw output. If your brilliant insights stay trapped in a boring table like this, all that incredible detective work you just did is essentially useless.
And that perfectly illustrates why data visualization is an absolute game changer. You have to translate those abstract math results into simple, intuitive pictures. Look at this bar chart, plotted out across the days of the week. That massive drop in sales on Tuesday, it is instantly impossible to ignore. Our brains just naturally spot patterns in pictures. By cutting out the cognitive overload, visualizations completely bypass the need for deep statistical training. You just see it. And when you illuminate the pattern that clearly, you dramatically accelerate the path to an actual solution.
Which brings us to our final step, Section 5, Solving Real-World Problems, the detective's conclusion.
So here is the crucial point where we bring all the clues together. How does this visual pattern translate into real-world action? Well, the pattern is spotted. Sales always plummet on Tuesdays. Because the digital detective made that insight completely undeniable, leadership can confidently take action without just guessing. They might launch a special Tuesday discount, right? Or optimize staff scheduling to cut labor costs for that day. The result? They solve the business problem. It optimizes operational efficiency, boosts ROI, and completely transforms abstract data into a tangible money-making asset.
Let's review the framework just one more time. What does a data scientist actually do? They combine domain expertise with smart math rules to collect data from vast digital pipelines. They explore that data to ensure it's absolutely solid. They analyze it by applying advanced predictive algorithms, and then they visualize it to craft a narrative that makes complex patterns obvious to everyone. By running these 4 steps, they become modern-day detectives, providing massive solutions to the enterprise world.
And that brings us to the end of our explainer today. But I want to leave you with a question to really think about. Which of these 4 steps actually sounds the most fun to you? Is it the deep, rigorous, investigative work of exploring the raw data? Or does drawing those final, impactful visualizations that instantly change a company's strategy appeal to you more? Let us know in the comments. It's a fascinating ecosystem, and it really proves that raw data is only ever as valuable as the detective interpreting it. Keep learning, and I'll catch you in the next explainer.
இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்ததுன்னா லைக் பண்ணுங்க, ஷேர் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணுங்க. Thank you for watching.